Introduction to API Gateway in Java REST Microservices. An API gateway is an essential component in a microservices architecture, especially for Java-based REST microservices. It acts as the single entry point for all client requests and routes them to the appropriate microservices. By doing so, it simplifies client interactions and improves security, performance, and scalability. The API gateway can be set up using technologies like Spring Cloud Gateway in the Java ecosystem, which offers extensive support for microservices. Key roles and functions. Request routing and aggregation. The API gateway routes client requests to the appropriate backend microservices. In scenarios where multiple services need to be called to fulfill a client request, the API gateway can aggregate the responses, reducing the number of calls and complexity on the client's side. Security and authentication. It serves as a centralized point to manage authentication, authorization, and request validation. This approach enhances security by ensuring that sensitive backend services are not directly exposed to clients. Load balancing. The API gateway can manage traffic load across various instances of a service, improving availability and resilience. It distributes requests evenly to optimize performance and avoid potential bottlenecks. Service discovery. In a dynamic microservices environment, services may frequently change due to scaling or redeployment. The API gateway integrates with service discovery tools, such as Eureka in the Java Spring ecosystem, to locate and connect to available service instances. Implementing an API gateway with Spring Cloud Gateway. In a Java-based microservices project, Spring Cloud Gateway is commonly used for API gateway implementations. Built on Spring Framework and Spring Boot, it allows easy configuration and supports features like request filtering, routing, and global error handling. Here's how you could set up a basic API gateway. Create a Spring Boot project. Start with a Spring Boot project and add Spring Cloud Gateway dependencies to handle routing and load balancing. Configure routes. Define the routes in application.eml or programmatically. These routes specify the destination microservice based on incoming request paths. Add filters. Filters provide pre- and post-processing options for requests. For example, adding an authentication filter to validate tokens before routing to services. Enable service discovery. Integrate with a service registry, like Eureka, for dynamic routing, so that the API gateway always routes requests to available service instances. Conclusion. An API gateway is crucial in a Java REST microservices setup, as it centralizes access, improves security, and simplifies client communication.